In this question we have to decide which amplitude squared versus distance graph corresponds to a particle that has the largest uncertainty in momentum. Let's start by looking at this equation from subtopic 12.1. PR is the probability of finding the particle at a distance x, psi is the amplitude of the wave function, and delta V is the volume that is being considered for the position of the particle. From the equation we can see that larger psi squared means a higher probability of finding the particle at the given distance. I have drawn two arbitrary amplitude squared distance graphs. Let's examine the differences between them. We see that the first graph is relatively thin and the area under the curve is relatively small. Since larger psi squared corresponds to a larger probability, the region where this particle can be found is relatively well defined and quite restricted. In other words, the particle will most likely be in the thin region where the amplitude is high. As a result, we can be relatively certain about the position of the particle, which means that the uncertainty in the position of the particle, delta x, is small. What we see in the second graph is that amplitude squared is high at most distances. What this means is that the probability is also high in many places. In other words, the particle can be in many different places, which means that we are relatively uncertain about its position, so delta x is large. Let's now consider this equation, also from subtopic 12.1, where delta x is the uncertainty in the position of the particle, delta p is the uncertainty in the momentum, and h is Planck's constant. Since the right side of this equation is constant, the product delta x times delta p also has to be constant or above a certain constant value, which means that if delta x is small, delta p is large. We have seen earlier that when delta x is small, the area under the amplitude squared distance graph is small. So in order to find the largest uncertainty in momentum, we have to look for the graph where the area under the curve is the smallest. From this we can conclude that the correct answer to this question is D.